Hello everyone, today I'm going to go over this merge sorted array problem. So you are given two integer arrays nums1 and nums2 sorted in non-decreasing order. So it's in ascending order. And two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in a non-decreasing order. The final sorted array should not be returned by the function, but instead be sorted inside the array's nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. So to understand this problem, we have quite a bit input. So we have, as we can see from the function declaration here, we have nums1 and integer array m. So the number of elements in nums1, the number of sorted elements. So the same deals nums2, also an integer array, and the number of sorted elements in nums2, also the length of nums2. So what we have right now is, for example, like nums1, 1, 2, 3, 0, 0, 0. Nums2 is 2, 5, 6. And we merge them to merge nums2 into nums1. So it merged back to nums1. So that is our point, that we do not we modify in place. So this we modify nums1 in place. However, you still have several ways to do that. You can build a separate list, separate array, and sort it, and then move it back to nums1. That's also an option. Another option is that you just modify in place. You just modify directly in nums1. So can you come up with an algorithm that runs all of m plus n times? So I mean, this question is almost exactly the same with the merge sort algorithm, the merge stage of the merge sort algorithm. So for the merge sort algorithm, we divided the array into pieces, cut it half until they only have one element. When they have only one element, they are itself sorted. So you can use the merge algorithm, the merge. So in merge sort, usually you will have a separate list to store your sorted elements. But here we would like to modify in place. So a very smart way to do it is to merge from the right hand side or merge from the largest elements. So in that case, we can put the largest elements into nums1 and then merge it, and so that we can simply directly modify nums1 and do that. So let's go to the plan. So actually this follow-up kind of also tells you how many times you need to run, because the merge state actually is the time complexity of O of n plus n. So so I will like write a for loop from the end of the nums1. So from for loop, so index. So the index would from n plus n minus 1 to -1 in range. So yeah. And then the first thing I would do is to so the merge state, we need some pointers. So we now have an index pointer point to the nums1, and we still need some pointers. So grade pointer I equals to m minus 1 for nums1. Pointer j equals to n minus 1 for nums2. So I'm going to compare. So if nums1, the pointer I points to nums1, nums1 I is greater than nums2 j, so which means at this position nums1 has a larger value than nums2. So I'm going to put it. So put nums1 I to nums1 index, and then I'm going to I minus minus. So else else, which means nums1 I is less than or equal to. So I'm going to put nums to j to nums1 index. So yeah, so and then for the same thing, I'm going to j minus minus. So in this case, somehow I or j will reach -1, where we should break the loop. So if j touches -1, which means all the elements of nums2 has been put into nums1, so we can actually break the loop. So if j is less than 0, I'm going to break the loop. And if j is non-zero, but I is 0, so if I is -1, so we can simply put all the remaining nums2 to nums1i. So yeah, after that, I need to also take care of the index. So here I should add one more thing. So if so else or so maybe I change the order a little bit. So maybe we try to combine it. If I change the order to this, if it's less than nums2 or I is less than 0, I'm going to do this. Else I would put I, yeah. So if nums2 is greater than nums1, I put nums2 into index. Or if I is already less than 0, I put the remaining j, the elements in nums2 into index, into nums1. Else, if nums1 is greater, and I'm going to, yeah. So that would work. I think that will work. So let's, so nums1 and nums2 and so create a pointer. I is equal to n minus 1, j is equal to n minus 1. And then index. So for index in range n plus n minus 1 to -1, steps -1, and then so if j is less than 0, I'm going to break, and if nums1 I less than nums2 j, or I is less than 0, I'm going to put nums1 index is equal to nums2 j, and then j minus equals to 1, and then else. So put the nums1 index is equal to nums1 I. What happens? I minus equal to 1. And after that, outside the outside the if else statement, I can index negative minus is equal to 1. Since it says it does not return anything, but when we try to debug, we still want to return it to see what happens. So I'm still want to return nums1. Or let's try not to return it. So define main, set things up to test it. So nums1, try the first example. So nums1 is equal to 1, 2, 3, 0, 0, 0. Nums2 is equal to 2, 5, 6. And go to merge nums1 and m is 3, nums2 3, and then print nums1. That should works. Oh, I forgot to if name go to main nums2 is not defined. Oh. Oh, there's still some. All right, you see, you get a result. So this method actually has all of m plus n time, and then the space complexity will be all of 1 because I only use some pointers here. I actually modify nums1 in place, so I can try to put this code here and run it. Yeah, that should work. Yes, it works. So I think that's it for this problem, and thank you.